Question number 33, it says, suppose f is a continuous function where f of x is greater than 0 for all values, and f of 0 is equal to 4. So we're just going to start there, and I'm going to draw a point. F of 0 is equal to 4, so our y-intercept is equal to 4. And it tells us that the graph is f prime of x is greater than 0 from between, or less than 0 and greater than 2. So it's going to be sloping up to 0, and sloping up from 2. So looking like this. It also tells us that the derivative is less than 0 between 0 and 2, so we're going to have sloping down like that. Okay, so we have the general shape of the graph, and then it tells us some information about the concavity. So we have 0 concavity at -1 and +1. And it tells us that we have positive concavity through this region here, less than 1 and greater than 1, and negative concavity when we have between -1 and 1. So we have negative concavity in here. And our slope graph seems to imply the same thing. Okay, so it looks like we have an inflection point in here at -1 and 1. We have a minimum and a maximum at 0 and 2. So if we were to answer these questions then, so part A says, can f have an absolute maximum? If so, sketch a graph, and if not, explain why. So f cannot have a max because of this portion of the graph here. Because that slope is increasing, it's just going to go up forever. So there is no max. Okay, so no absolute max. Okay, we do have a local max at 4. For part B, it says, can f have an absolute minimum? If so, sketch a possible graph. If not, explain why. So if we take a look at this graph here, we know that the graph has to be greater than 0, so we can't cross the x-axis. And we could maybe draw it like this. So we have a graph, we have, on this looks like it's curving, has concavity. And we can draw a graph where it goes up through there. We have a max, and at 2 we have a min, and then it's going to keep on going up through here. Okay, so there's our minimum point at 2, and we have our inflection point at 1. We have another inflection point at -1, and with that inflection point, it could start to go like that. Okay, so I'm just going to exaggerate it a bit more, and if I let this have a horizontal asymptote above that point here, the minimum local min at 2, we know that this has an absolute minimum. That absolute minimum would then occur right at the absolute minimum occurs right there. Okay, so yes, this is possible. Okay, so looking at part C, it says, sketch a possible graph for f that does not achieve an absolute minimum. Well, that would mean that it's got to go below that point there, and because it's always above 0, for that to happen, and the only way this could happen is if the horizontal asymptote, as it's curving up, sloping down and curving up, concave up, is this if the horizontal asymptote is along 0. And this means that it's going to just keep on be concave up. It's sloping down to the left or up to the right, has positive slope. Okay, so it follows our slope chart as well. And it stays above 0. So we have that condition here. And this does not achieve an absolute minimum because it never reaches that minimum. It's always going lower and lower and lower. So technically it has no absolute minimum. So it is possible, and it would mean that the horizontal asymptote represents where it's going to its lowest point.